Good afternoon, everybody, or at least all two of you. All right, welcome to 407. Can you guys hear me okay?
Yeah.
Great. All right, so I know it's a bit early, but if you guys have any questions about the class or anything, go ahead and feel free to ask it, but I'll wait until 2:32 to start.
All right, thank you.
Sounds good.
Hey, everybody that's just coming in. So we still have about 10 more minutes until the lecture starts, but if you have any questions, go ahead and ask. Hey guys, so it's we have 5 more minutes until the lecture starts, but if you have any questions or anything I can answer before we begin, don't feel shy to ask. You can either turn on your mic and ask, or you can send the message to the chat, and I can answer from there too. But 5 more minutes, we'll probably get started today.
How was your winter break?
It was good. Yeah, it was eventful actually. So I moved to a new place. So this place is a little bit bigger. So before I was kind of like sitting in my living room, and then like whenever my then girlfriend at the time would come in, she would kind of show up on stream. But now we're in a slightly bigger place, so I'm in a different room. So it's a bit nicer. I proposed to my girlfriend, so we're engaged now. So that's very exciting. So
Congratulations.
thank you.
Congratulations.
Thank you. Yeah, so it was good and very eventful, but
Congrats.
a lot of good stuff happening. How about you guys? How's your break?
Picked up a lot of work hours.
Cool. Where do you work?
Oh, grocery store, meat clerk.
Nice.
2 of our guys were indisposed, and so they just asked me if I could pretty much work almost every single day.
Oh man, that's tough, but I'm sure they appreciate that a lot.
I applied to Wingstop and they rejected me. So
Oh.
I guess that's how much a third-year engineer gets on a resume.
I see. I see.
They don't want you to over-engineer the wings.
Bro, that looks like the easiest job ever.
I just noticed it looks like I somehow brought a egg full of praying mantises, because I see a whole bunch of baby ones on my desk right now.
Mm.
You have a lizard or something?
No, it's just like I noticed there's like I saw a small praying mantis, like, oh, that's weird, and then I see there's a lot more. I'm just trying to figure out where the hell did I pick up one.
Oh, I see.
How did you propose, Professor?
I took her to the same place where we had our first date. So it's this park in Hacienda Heights, actually. So it's called the Shabaram Park. And so we hiked up to kind of the hill up there where you get kind of a nice view of the town, and I proposed there.
It's cool.
Yeah, I went on Christmas, so I was hoping that it would be fairly deserted, but it was kind of awkward because we were on the trail, and then people kept coming, and I was kind of like waiting for it to kind of disperse a little bit.
Okay.
But at one point, I just, the only person there was just like an old Korean grandma, and I just went for it. But it was nice because then she was able to take some pictures for us too. So.
That was cool.
Okay, it's 2:30, so let's go ahead and get started today. All right, good afternoon, everybody. So this is our first lecture for EGME 407, so Introduction to Heat Transfer, or I guess it's just called Heat Transfer now. So my name is Professor Justin Tran, and this is going to be the start of another virtual semester. So I don't know about you guys, but it's, this is going to be our third time, well, I guess second time and a half going around this this virtual setting. So Zoom lectures kind of get tiring after a bit, but we got to do what we got to do in the face of a global pandemic. So this is a big class. So I know this this class is probably one of the last ones that a lot of you guys take. And I know it also has kind of a reputation to be a little bit hard, but we're going to do the best we can, and we're going to learn about heat transfer. Okay. So before we begin, I just want to say, I know some people are still kind of trickling in, so I'm still kind of stalling a little bit. But I just want to, before we begin, how's everyone doing today?
Good.
Good.
Just getting ready for all my classes.
Yeah. Is this your first class, everyone, for today, or is this? Or have you guys had some other classes today?
This is the second.
Okay.
I technically had a class on Saturday, but I was waitlisted, so I missed it.
I see. Yeah, the first week is always a little bit weird because I know, people are still kind of moving around classes a bit. I know a few people emailed me. They said they're still trying to get in. So when we're in person, it's a bit easier because you can just show up to the class. But for virtual, you actually need the Zoom link. So I try to give those out as much as I could. But if you guys know anyone else that would like to attend the lectures, just go ahead and share the link with them. It's a public Zoom room, so. Luckily, I haven't had any problems with Zoom bombing, but that might change this semester. But for now, it's a public room, so anyone can join. Okay. So does anyone have any just really quick questions to ask just about the class or the format or anything before we get started today? Okay, so if there's no questions, let's go ahead and get rolling. But at any time, if you have any questions, just go ahead and stop me and interrupt me. I'm pretty laid back with that stuff. So if you have a question you want to ask, just go ahead and ask it. Yeah, weather is weird. It feels chilly in my place right now, but I know last night it was thunderstorms. But yeah, now it's nice. Oh, okay. Computer froze for a second. Okay. So just a little bit about myself. So my name is Professor Justin Tran. So you can call me whatever you want. So it's I'm not particular about it. So you can call me Professor. You can call me Justin. For a lot of you guys, I'm not that much older than you. So it is a little bit weird for me to be called Professor from people that are so close to my age. So just do whatever feels most comfortable with you. I offer this every semester, but no one's actually ever taken me up on it. But, if you want to call me, something crazy like Dick Face or something like that, that's okay too. Preferably not out loud, but if you email me and say, hi, Dick Face, I'll still respond to you. But, maybe not in the middle of lecture like that. Okay? My email is here. So I know some of you have already emailed me, which is great. But if you haven't sent me an email yet, my email is very easy to remember. So it's called justran@fullerton.edu. Maybe I stole the email from some running club at Cal State Fullerton, but that's okay. Right? So I'm from around here. So I grew up in Cyprus. So if you don't know where that is, that's about maybe like 10 miles west of the campus. So I'm very familiar with this area. A lot of my buddies from high school actually went to Cal State Fullerton too. So I'm very familiar with the school. Right? There's a question in the chat. So someone wants to know how old I am. So just last month, actually, so my birthday's in December, I turned 30. So I just turned 30 years old. Right? So a little bit about my education background. So I got my bachelor's from UCLA, then I did a master's at UCSD, then I did my PhD at Stanford. So all of that was in mechanical engineering. And in terms of research, a lot of my research centers around using, engineering tools to study heart and blood disease. So I'm actually teaching a class centered around this this semester too. So if you're looking for another technical elective, there's a new class called EGME 442 where we discuss a lot about how do we use mechanical engineering to study blood flow basically. Okay, and just naturally being an instructor in an engineering department, I'm also interested in better ways to teach education as well. Okay. Oh man, my laptop is freaking out. Okay. So let's talk learning objectives. So if you've had me as a professor before, you should be pretty familiar with this. But if this is your first time, I usually like to start every lecture with what I call our learning objectives. Okay. And so you can think of these learning objectives as kind of like an outline of what we're going to discuss for today. So I usually post these, these are kind of the first thing that you should see usually when you come into the lecture. Today is a little bit of an exception because it's the first day. And they're going to discuss what we're going to talk about, but it goes a little bit more than that. So what you'll notice from these learning objectives that they start with a verb each time. Okay, and I do that on purpose. So the reason I do that is it's kind of like a way to kind of test. Not only is it an outline for what we're going to cover, it's a way for you to test whether you really understood that, right? And so let's take this first learning objective as an example. So the first learning objective is to list applications of heat transfer. Okay. And so what that means is that by the end of today's lecture, you should be able to do this action right here. Okay, so you should be able to list applications of heat transfer, as by the end of today's lecture. So if you feel like that you can do that by the end of the lecture, then you've gotten everything that you've gotten, that I want you to get from the lecture. Okay? Of course, you should be able to do all of these things. Okay. But there's going to be a regular occurrence. So later when we tour the Canvas site, you'll see that the learning objectives will be there as well. And I use these all the time when I write your homework assignments, when I write your exams. So, really pay close attention to the learning objectives because I really design the class around these things. Okay. Okay, so let's jump right into it. So, this is a class on heat transfer. So I think the first question that, that's fair to ask is, what exactly even is heat transfer, right? And so, the first place that you can look is to, look in your textbook. And so the textbook defines heat transfer is a way that heat transfer is thermal energy that is in transit due to a spatial temperature difference, okay? So that's fine. It's correct. So there's nothing wrong with this definition, but it's a little stuffy, especially for your first day, after winter break, almost a year in a pandemic, right? This is not kind of the first thing that you want to see when you come into a class, right? So I came up with kind of a little bit of a better definition that, I think will hopefully simplify this a little bit more. Okay. And so the definition that I like to use for heat transfer is that heat goes from hot stuff to cold stuff, right? So I think everyone kind of basically understands what the concept of temperature is, right? And so when you have something hot and you have something cold, the heat will go from the hot stuff to the cold stuff, and that's basically heat transfer, right? So that's it for the class. We can go home now. No, that's not true. So please stay, right? And so no matter what kind of heat transfer that you have, it's always going to go from something hot to something cold. But what we're going to be learning in this class is quantifying, how much heat it's going to go, right? And depending on what kind of modes of heat transfer there's going to be, that's going to affect how much heat is going to move as well. Okay. Not only that, is we're also going to discuss, how do we actually use heat transfer within engineering, and how does this factor into kind of normal engineering work. Okay. Okay, so first let's talk about some examples. I think this is kind of the examples kind of form the basis of engineering, right? And so let's take an example of just cooling some drinks inside a cooler, right? And so if you've gone to like a tailgate, or you've gone to the beach, or you've gone hiking or stuff like that, you probably are familiar with the situation where you have some beverages and you want to keep them cold, or get them cold, so that they'll be nice and refreshing after you go hiking or something like that, right? And the way you do that is you put these drinks inside a cooler filled with ice, okay? And so in this situation, maybe you spot the drinks at the store, and the drinks are kind of like room temperature, right? So by putting them in the ice, the heat is going to be transferred from the warm drink into the cold ice, okay? And eventually, enough heat is going to be sapped away from those drinks, such that they'll be kind of cool and refreshing when you drink them, okay? And so, everyday examples we have heat transfer. Okay? Another example of heat transfer is boiling water, right? So I know it's been kind of a long pandemic. So if you've been making a lot of instant ramen, this is probably a familiar sight to you, right? So in this situation, we have heat that's coming from the fire. Fire is very hot. Heat is transferring from the fire to the water, and eventually that's going to bring up the temperature of the water until it's boiling. Okay. And here's another one that you might see a lot, in the pandemic, right? You're microwaving some food. Microwaving a burger, might not be the best idea, but that's something that you can do as well. Okay. And so a microwave is actually, really interesting because it uses a form of heat transfer known as radiation, okay? Which sounds really scary, but it's just kind of a different form of heat transfer, right? And that's why microwave is so good at heating up food really quickly, because it doesn't rely on what's called conduction or convection, which is kind of the more traditional modes of heat transfer, okay? Okay, and so with this, I want to take a little bit of a step back, and I want you guys to kind of share. So what other kind of examples of heat transfer do you guys see either in your everyday life or in engineering, or any examples of heat transfer that you want to learn about in this class? So just go ahead and shout them out, put them in the chat, and we'll do this for a few minutes.
HVAC.
HVAC, perfect example. So, whenever you have a building, we have HVAC, for those who aren't familiar, it stands for heating, ventilation, and air conditioning, right? So that's basically how you control temperature in your building. So that's great example, okay? And so someone said in the chat, a car's radiator fluid, excellent example. So that's, how car engines and inside the car, the temperature is regulated, okay? Another comment in the chat says inductive. So inductive heat transfer, I think you're probably referring to like an induction stove. So that actually uses magnets to actually heat some stuff. So I actually don't know the full physics behind that, but it is really cool. So that is kind of definitely another big area of heat transfer. Right?
What system would be used in an environment that has no air in it, or like no like space?
Yeah, that's a great question. So So actually, the first two modes of heat transfer that we're going to talk about, conduction, convection, you need what's called a medium. So that's kind of what you refer to as like air or some kind of solid, right? But what if you don't have any particles, right? And so in those situations, heat's actually transferred through radiation, right? And so radiation actually, we feel that every day, and that's how heat transfers from the sun to the surface of the earth, right? Because in space between the sun and the earth, there's no matter, right? So there's no molecules which are used to transfer heat. So in that case, heat's actually going to transfer through electromagnetic waves. That's what the sun emits. Yeah. Another example in the chat is sweating. Absolutely. So sweating's actually really cool because it's a lot of people think of sweating as kind of a gross thing that people do, right? No one likes to shake someone's hand with has sweaty palms, but sweating's actually your body's way to actually regulate temperature. So when your body's overheating, your body exudes some fluid, in order to cool yourself off. Right? Bodies in a room, yeah, exactly. So the more people that you have in a room, the more warm it's going to be. And a lot of times I feel like a lot of times people forget that, but our bodies themselves, we exhibit a lot of heat, and so you put enough people in a room, it starts to get really stuffy and sweaty. Yeah, great examples, guys. All right, another example from the chat is electronics heating up from use. Yeah, perfect example. Actually, we're going to watch a video later today, talking about that too. And electronics is actually really interesting too, because if you follow kind of the field a bit, heating or actually I should say cooling is kind of the limiting factor right now, because all the big chip manufacturers and people that make graphics cards, they can make graphics cards that are chips that perform way better than what's kind of commercially available now. The limiting factor is heat, right? Because all these chips and stuff, they produce so much heat, they basically just melt themselves before they can actually achieve that amount of power. So, there's a lot of research in electronics actually based around heat transfer to see how can we effectively cool these devices. Yeah. Friction, yeah, excellent example. So, when you rub two things together, a lot of some of what's called the mechanical energy, of those of two objects rubbing together gets converted to heat. And that's through friction. Yeah, great examples, guys. So I'm going to have to cut it off here because we do have to move on. But if you have anything else, definitely put it in the chat, and we'll come back to it later in the lecture. But yeah, great example. So looks like a lot of you guys looks like you guys have a really good idea of what heat transfer is, which is great, because I think anchoring yourselves in those examples and those applications will really help you as we go throughout the class. Because when you're studying anything new, if the material just kind of exists as just kind of numbers and formulas to you, that's not, it's really hard to learn that thing. At least for me, it is, right? Because you can memorize a formula, you can memorize numbers, but it doesn't mean anything unless you have kind of physical applications to anchor it into. And especially as engineers, you know, as engineers, we're always working in applications, right? And so the fact that you guys, you know, can come up with all these examples, you know, is really great, you know, for us moving forward. Okay. Oops. Okay. So let's talk about a little bit about you know, how does heat transfer actually happen? And so what I mean by that is, you know, what are the modes of heat transfer, right? So let's draw kind of a flow chart here. And so in the middle here we have heat transfer, okay? And if we kind of extrapolate from this a little bit, you know, we'll see that we'll have, we're going to talk about 3 different, what I call modes of heat transfer. And so one of those is called conduction. So that's the first thing, that's going to be our first unit in the class. Our second unit is going to be based on convection. And then our third unit is going to be on radiation. So, you know, this class kind of takes part in 3 different chapters, okay? And so, you know, we're basically going to be going through each of these kind of individually. And we'll define what each of these are kind of later on in the presentation today, okay? Okay, so first let's talk about conduction. So conduction is kind of the first, you know, mode of heat transfer that, you know, that we can study. Most of all, just because it's kind of the easiest one to quantify. Okay, and so the definition for conduction is conduction refers to heat transfer across a stationary medium, and by medium I mean some kind of substance, right? And so it could be either a solid, a fluid, or a gas. So it could be any. A medium can be anything, as long as there's some molecules in between location 1 and location 2. You know, you can have heat transfer through conduction. Okay, and so as you can imagine, you know, conduction is really important because if you kind of are sitting at any place, you know, on Earth, you know, there's all heat transfer by conduction is always going to be possible because there's always going to be some molecules that are surrounding you, right? Even just sitting in your, you know, in your chairs right now or wherever you are, you know, you're surrounded by air particles, right? And so just by that, you know, we can have heat transfer for conduction. Okay, and so the only place I think, at least engineering wise, that you don't really have conduction, as was mentioned before, was in space, because in space we don't really have any of these molecules. Okay, and so if you look kind of microscopically about what's happening through conduction, is that conduction is really just kind of 2 molecules. You know, one might be hotter than the next one, and they're literally just going to pass, you know, energy from one molecule to the next one. Okay, and so you know, that kind of gives you an idea of, you know, what conduction is. Okay, so you need to have molecules. And so here's some examples of conduction, right? And so on the left right here, I have a metal spoon that's inside, you know, a hot cup of water. Okay, and so what's going to happen to that metal spoon is that because the end of that spoon is sitting inside, you know, something that's really hot, heat is going to be conducted up through the spoon and eventually burn this person's fingers if he doesn't kind of move the spoon. Okay, and so what's happening there is that the molecules inside that spoon are basically, you know, exchanging heat or exchanging energy with each other. Okay, and so another example of conduction is on the right. So if you hold someone's hand, then, you know, what usually ends up happening is one person's hand is warmer than the other one. Then because you have direct contact, you know, you're going to have heat conduction that occurs as those molecules kind of pass energy to each other. Okay. All right. Any questions so far on conduction or anything that we've talked about today so far? Okay. Okay. So let's talk about convection. Okay. And so what convection refers to is any heat transfer that takes place to a moving fluid. Okay. And so in order to have convection, you need to have a fluid and it also has to be moving. Okay. And so convection, you know, depending on who you talk to in the field, some people think that convection actually doesn't exist, right? And so what I mean by that is that, you know, the reason we have the term convection is that whenever you blow fluid over something, it generally enhances heat transfer, right? And so going back to our electronics example from before, you know, one way that you can enhance, you know, heat transfer or cooling to your computer is you have a fan, right? So most computers come with a fan, you blow air over it, and you know, that cools your computer a lot more efficiently than just letting it sit, okay? And so what's happening there is that, you know, when you blow fluid over something, what's happening is that, you know, your hot surface is transferring heat to the fluid that's in contact with it. And then those fluid particles that were hot are immediately swept away into the into the stream. Okay, and then in its place are replaced by new fluid particles that are not as hot as before, and so you can have heat transfer there too. Okay, and so when people say that convection doesn't exist, what they refer to is that convection is simply just conduction, and then you just move it away really quickly. Okay, you can almost think of it as like if you're trying to empty out like a say you're trying to empty out like a bunch of sand from sandbags, right? And you can you're trying to put it into a bunch of buckets, right? So you can fill one bucket and then you move it to the next bucket. Okay, and so just by moving the buckets, we're creating more transfer than if there wasn't any. Okay, and so generally when you have convection, this results in kind of more heat transfer relative to conduction. Okay, so let's look at some examples. Okay, and so on the left right here, you have a young child, and he's about to eat this soup. Okay, but the soup is really hot, right? And so generally when we try to drink like a hot liquid or something, right, what's kind of our natural instinct to do? We blow air over it, right? Maybe not as much now because of COVID, but it's what the blowing does is that it blows kind of the hot air that's right next to your spoon and replaces it with cooler air, right? And so by creating the steady stream of moving fluid, you're going to cool the soup a lot faster than if you just kind of let it sit on the countertop. Okay. And on the right here, I have a little comic that illustrates wind chill. Okay. And so if you've ever stepped outside on kind of a cold, windy day, right, or a cold day, right, you know that you feel a lot cooler, or it feels a lot colder if there's wind blowing, right, or if there's wind chill. That's a factor, right? And so if you step outside and it's maybe like 45 degrees, but there's no wind, that's something that's tolerable because that's not as bad. Okay. Because if there's no wind, then you only have basically just conduction that's coming out, right? But as soon as you add wind to the equation, even if it's the exact same temperature, by adding wind that blows, you feel so much colder just because you have convection that's going on instead of just conduction. Okay. All right, so let me see. There's a comment in the chat. So example from work is when I thaw out shrimp, I let water run over and fill the top and cut a hole. Yeah, that's perfect. Yeah. So when you're defrosting, something from your freezer, so if you let water run over it, that's a great example of convection because then that water is helping to transfer the heat a lot more effectively than just letting it heat up through conduction. Okay. Yeah, swamp cooler. Yeah, exactly. Yeah, that's another great example too. So, yeah, basically whenever you have like a moving fluid, that helps with heat transfer. Okay. Like another example that probably a lot of you are familiar with is kind of your cooling fluid inside your engines, right? And so that fluid is kind of basically constantly flowing throughout the engine to kind of cool it. And the fact that it has a velocity helps maintain the temperature a lot better, right? And so we'll be going over heat exchangers later on in the class, but and kind of the central mechanism for that is convection. Okay. Okay. And so let's quickly go over the last form of heat transfer, which is radiation. Okay. And so radiation is kind of the black sheep of the bunch, right? And so what I mean by that is radiation, radiation doesn't require a medium, right? So it doesn't require molecules at all. Okay. And so radiation refers to heat transfer that's through electromagnetic waves. Okay. And so like we talked about before, the sun, heats the earth through, electromagnetic waves. Because in space, there really is no particles for the sun to transfer energy. Okay. And so, it's not only the sun that radiates heat. Actually, all bodies that have, some kind of temperature, which is every object, in existence so far, right? And so you basically have radiation all the time. Okay. But because the form of radiation is electromagnetic waves, typically when you compare that to conduction and convection, radiation is actually really, really, really small. So for most situations that that don't have to deal with space, a lot of times we can ignore radiation. So that's why I kind of save it for last in the class, because for a lot of applications that don't really have to do with aerospace, radiation is mostly ignored, but it's still there. It's just kind of really, really small. Okay. Okay, so here's some examples, right? So we talked about the sun, and so the sun, because there's no, there's no, medium in space, the sun is going to heat the earth through radiation. Okay. Another popular form of radiation comes from fire, actually, right? And so I know I said that, radiation doesn't occur much on Earth because we have a medium, but if you have something that's actually really, really, really hot, radiation actually plays a role there. So, heat is going to radiate out from fire, pretty well too. So that's kind of the other application. But for most other things, we can kind of ignore radiation. So we'll kind of save that for the end. Okay. Okay. And so, that's just kind of a very quick overview of the 3 different modes of heat transfer. So, we'll be revisiting all of these, in much more detail throughout the class. But, I want you to kind of have these 3 different modes in mind as we kind of go throughout. Okay. And so we can actually expand this tree to be, to cover much more of what we're going to cover in the class. So you can kind of think of this, this bubble chart right here as kind of like an outline for the entire class, right? And so we're going to start here with conduction, and then, we're going to go through all these different bubbles, okay? And then we're going to go to convection and going to do kind of the same thing, okay? And so, obviously, you're not going to know, half of what's in this diagram right now. But what I hope is that, as we go through the class, you can come back to this bubble diagram and say, yeah, we did conduction, we did fins, we did, 1D planar conduction, we did heat exchangers and things like that, okay? And so you can kind of think of this as kind of like an outline for the entire class. Okay. Okay. So there's a question in the chat. So the question is Earth's core considered as a type of radiation? Yeah. So Earth's core is very hot. So definitely it's radiating heat out. But because it's in contact with all the other matter on Earth, there's still going to be heat transfer through conduction and convection as well. Mostly conduction because there's not that much moving down there. So so the Earth core is definitely radiating heat, and it's also transferring heat through conduction as well. Yeah. Mm-hmm. Okay. And so let's talk a bit about why heat transfer is important, right? So why are we studying this, right? So this is a required class. And so as a department, we say that you need to take heat transfer before you graduate here, right? And so, why do we make you take this, okay? So heat transfer, it's actually really important in terms of energy, right? And so there's a statistic out there that, says that, a lot of the energy that we consume as humans, a lot of it is actually lost to heat, right? So as an example, when you fill up your car with gasoline is basically just liquid energy, right? Energy that's going to be used to propel your car forward, right? And so out of all the energy that's packed inside gasoline, cars are actually only able to use about 21% of it, right? And so only 21% of the energy that's in gasoline actually goes towards moving your car forward, right? And so that's kind of an old statistic. So I think it's a little bit better now because car engines are better, and of course we have hybrid cars and electric cars and things like that. But that's just to kind of give you an idea of how much energy is actually lost to heat, right? And so, there a lot of, research and a lot of engineering is still going on now to say, how can we make better use of energy where we don't just kind of randomly lose it to heat, right? And so, if you get into energy or you get into, any kind of, automotive and things like that, heat transfer is going to be a really big, important part of your work. Because otherwise, if you don't pay attention to that, you're going to end up with some very inefficient machines. Okay. Okay. And so I have a video to show for you guys too. Kind of building off that electronic stuff. So if you've kind of had me before, you know that I love to play, video games. So that's kind of one of my big hobbies. So one of my dreams one day is to kind of build my own kind of building gaming computer, and just because, I'm an engineering professor, I might have some kind of crazy cooling system like this. So, we'll watch this for a few minutes just to kind of take a break from my voice, and you can kind of see, what some people have done to leverage heat transfer for, their own personal gaming. Okay. Can everyone hear the video okay?
Yeah.
Yeah, I can hear that well.
Great.
Having a badass computer is a must for many gamers, but besides the extraordinarily powerful source and a top-notch processor and GPU, everybody knows that A well-optimized cooling system is mandatory. In order to keep their rigs at the right temperature, people have come up with some pretty wild ideas, and in what follows we'll be presenting 10 of the craziest ways some modders try to cool down their precious PCs. A very resourceful user thought of a brilliant idea to cool down his computer, a turbine from 1990 Mitsubishi Eclipse. The turbocharger is able to move air through the PC so that it can provide the perfect cooling method, making it a weird yet effective way of keeping temperatures down low when overclocking your machine to engage in some really heated video gaming sessions. There's nothing human imagination and a little bit of ingenuity can't do. When it comes to innovation, the Russians surely take the grand prize, and this crazy modder stands as proof of that. He decided to keep his computer cool in some of the most ordinary, but yet creative ways, by sticking it in the freezer. The nice part is that you'll have your fair share of polar air standing by in front of your rig, and this should be a blessing on a hot summer's day. In addition to that, the beer six-pack will be at arm's length, so we think that's a win-win situation.
Russians, man.
Why use only the original fan slots your computer comes equipped with when you can totally overkill and build an entire case out of them? When cooling down your PC, there's no overdoing it. You just have to be bold enough to step up and make an entire armor of plastic fans, glue them together and connect them to your main power source. And besides the practical side of this project, you'll also have the coolest PC in the neighborhood. Some people believe that air flows better if you totally dismantle your machine and hang its components on some wires, making a modern art display out of them. It might not look like the most elegant rig in the world, but it does the job, and what's not to like about it? On the plus side, you don't need to add any extra gadgets like we saw in other examples from our list. This project can be done by everybody with a computer and a taste for extravagant setups.
Okay. So I'll stop it there. So, there's still 6 more. And so if you're interested in seeing the rest of it, the lecture slides are posted online. But, as you can see, heat transfer is really important for these kinds of machines. And people have been really creative in how they can, cool their machines. Yeah. Yeah, it's. I stopped on that one because there's the meme of that guy at the Counter-Strike party being duct taped to the ceiling. Yeah, it's a classic image. Okay. And so one more, I think this is the last one, reason why heat transfer is important. It's also important in biology, right? And so actually, I'm really happy someone brought up the example of sweating earlier, because that's one way that your body actually regulates temperature, right? But there's other ways that your body can regulate temperature too. Your shivering response is a way to generate more heat. And temperature is really important for your body, because there's tons of different biological and human processes that are occurring in your body at the same time, right? And a lot of these processes are really dependent on the temperature, right? Because if something is too hot or too cold, some parts of your body just won't work, right? And so it's really important for your body to regulate the temperature in order for it to function properly. Okay? That's why, pneumonia is a thing, right? That's why, your mom always yells at you to put on a sweater before you go out on a cold day, right? Because if you don't, then you get sick and, lots of bad things can happen. Okay. Okay. So are there any questions up to this point, we've kind of just covered, just an introduction of what this course is. And what I want to do next is, before we get into the syllabus, I do want to tour the course website a little bit. And then we'll go over the syllabus. But on anything that I've covered so far, are there any questions?
One question: is the sweating considered the main part of cooling down, or do we cool down majority of the time through radiating through our body?
Yeah. So sweating is one of the main ways to cool down, because it encourages what's called phase change, right? And so you put a liquid kind of on top of your skin. And what's happening is that that some of that liquid's going to evaporate. And what we'll learn later on is that when you evaporate something, that causes a very large amount of heat transfer away from your body. So sweating is kind of the main thing. Radiation helps too, but again, when you compare it to like conduction or convection, it's just usually not as high. Okay, and you'd be surprised too. So your body also kind of naturally does a lot of things to kind of encourage heat transfer too. And so, when you're you'll naturally kind of want to take off, clothes, the things that impede you from getting, heat transfer, right? And you'll kind of, naturally kind of also kind of want to spread yourself out, right? And by doing so, you kind of maximize the amount of surface area of your skin that's exposed to the air, and that also kind of encourages heat transfer too. So it's there's the mechanical stuff, which is the sweat that's evaporating from your body, but psychologically and mentally there's a lot of things that your body does to regulate its temperature as well. Yeah. All right, any other questions before we tour the course website? Okay. Oh, question. Yeah. So someone in the chat commented that if you live in the desert, people actually put on layers of clothes to sweat quicker to cool down to work in the summer. That's true. Yeah, I have heard that too. So basically, they're basically encouraging the sweat response by putting more layers of clothes on. So yeah, there's definitely lots of different ways to look at it. Yeah, or lots of different strategies to cool your body down. Okay. And so here's our course website. And so you can see it's on Canvas. And so I think, by this time, all of your courses should have moved to Canvas. I think, last semester was, I think, the last one that, we could still use titanium. And so hopefully, you had at least some professors that used Canvas last semester. So Canvas will be our mode of, for our website this semester. Okay. And so when you first click on the class, you'll arrive at the home page. And so this is the home page here. So you can see, up here has my information. So you can click this. There's a quick bio here, right? So that's like my Tinder profile for teaching, I guess you can say. Here's my email address. Okay. And so you can click on this. I think it'll let you email me. Okay. Or you can just copy and paste that into your email service, whatever you want. Okay. Here's our class time. So, we are currently in the middle of this. So it's Monday between 2:30 and 3:45. Okay. Here we have the course description. Here we have the course level learning objectives. Okay. And so what these are is that, by the end of the course, you should be able to, do all these things. Okay. You can download the syllabus here. So you can just click this link and it'll download the syllabus. Here's all of our Zoom links. And so, I put these on the homepage just to be kind of easy access. So here's the one for the lecture, which, thankfully everyone was able to do today. And here's the links for all the office hours too. So I have 3 sessions for office hours. So I had one this morning from 9 a.m. to 10 a.m. I have office hours tomorrow from 1 to 2 p.m. And then my last office hour sessions on Thursday from 2 to 3 p.m. Okay. And so my logic with the office hours is to kind of spread these out kind of as much as I can, because I know everyone's schedule is a little bit different. So I don't like to stack all my office hours at the same time. And so I try to have one. Usually I have one in the morning, one in the early afternoon, and one in the late afternoon. But because my teaching schedule is really, tail heavy this semester, so I teach in the evenings, I can't really have one kind of in the late afternoon. So that's why the Thursday office hours is from 2 to 3 p.m. Right. And so yes, so if you just added the course, last minute, or you're still kind of in the process, I think they'll add you to the Canvas site automatically. But if by tomorrow, if you're still not on the Canvas site, definitely let me know, and I can manually add you as well. Okay. Yeah. So that's why kind of the office hours are the way they are. But if these times don't work for you, or if you want to ask a question, kind of the day before homework's due, I'm always available, to make an appointment too. So just shoot me an email or shoot me a message on Discord, and we can set up a time and meet as well. But these are the times where, I'll be kind of available for everyone, and I'll just kind of sit in a Zoom room. So you can just click these links, pop in, and you can ask questions. Okay. Okay. So next, I have our link to the Discord server. Okay. And so this is something, that I'm doing, because it's a virtual instruction. So usually, we have a physical classroom, so it's, kind of easy for you to kind of meet people and talk to people and things like that, organize study groups. But with the virtual, it's a lot more difficult. So my logic with this Discord server is to kind of give you guys kind of a virtual place where you can kind of talk about the class, ask each other questions, ask me questions. You can summon me if you wish, but it's basically just a way to kind of, informally meet people and kind of, organize things in the class. Okay. And so when you click this link, it'll give you kind of the option to join our Discord server, which is shown right here. Okay. And so if you, this is not a requirement. So, if you don't want to join it, that's perfectly fine. But if you do want to join it and kind of meet other people in the class and organize study groups, that's kind of what people used it for last semester. You can go ahead and join that. Okay. And when you join, you'll see kind of various channels here. And so I'll use the announcements tab. Looks like a lot of people have joined now, to kind of send any announcements to the class. I'll also put them on Canvas as well. But I also have this channel for introductions. So if you kind of want to introduce yourself, so for other people, you can go ahead and just leave a message here to say your name, and you're open to studying, stuff like that. Okay. I have a channel for questions. Okay. And so if you have any, if you want to ask a question about the homework or anything and other people can answer, you can go ahead and do that. Okay. And there's also a channel for memes. So, if you want to share jokes and stuff like that, you can make fun of me here if you want, that's fine. So I thought I'd give you a place for that too. Okay. And so I'll tell you right now that my notifications for this channel, for this server are off, because it gets kind of crazy sometimes when people are asking a lot of questions. But if you do want to ask me a question that people are having a lot of trouble answering, you can just go ahead and tag me. So just go ahead and use the @ sign and just say, @ professor, and say, hey, and then you'll summon me, and then I will show up in the chat and answer your questions. Okay. Okay. So that's the home page. So, I designed the home page to kind of make a lot of things accessible. Oh, one more thing. So the outline. Okay. And so if you want to view kind of week by week content, this is kind of your stop to do it. Okay. And so as we go about in the semester, all of these links here will become active. Okay. Let's go ahead and click link week 1 right here, and you'll see kind of the summary and the outline for this week. Okay. And so every week I kind of write kind of a little bit of a couple paragraphs to kind of describe what we're going to learn this week. Okay. I have our learning objectives, right? And so these are all the learning objectives that we're going to try to accomplish in the week. Okay. I'm also going to put the recorded lectures. Okay. And so one nice thing about Zoom is that it records our lectures automatically. So right after the lecture is done, I tend to upload the lectures onto YouTube. And then once that process is complete, then I'll put the link here so you can go ahead and view our lectures, afterwards. Okay. And so usually most weeks have 2 lectures, so I can leave 2 slots for it. Okay. Any assignments that I assign for the week will be here as well. So you can go ahead and click this, and this will take you to the homework assignment. Okay, so we'll talk about that in a bit. And any files that are related for this week, you can find here as well. Okay, so lecture notes, homework solutions, study guides, basically any material that I want to give to you guys, I'll put here as well. Okay, and so when you're looking for a certain kind of material for a certain week, you should check the weekly pages for that, first thing. Okay. And so if you go back to this page, you can see you can download the slides from today's lecture. Okay. And then maybe on Wednesday, we're going to start the lecture notes on planar conduction. Okay. Okay. So that's the weekly viewer. Okay. Next, let's look at the announcements tab. So here I'm going to send announcements to the class. And so anything that I write in this section, it will automatically send an email to you guys. So you don't have to view here. But if you want to view the text for that announcement, you can come back here and view them. Okay. The next tab is assignments. So here you'll see a summary of all the assignments that I've assigned. Okay. And so this is where I'll put the homework assignments. So you can check here for that. Okay. The next tab is grades. So you can come here to see a summary of your grades for the class. Okay. Right. The next tab is people. Right. And so you want to see the names of everyone in the class. You can come here and look at that. Okay. Okay. So the next tab is probably probably one of the most important ones. So you can find all the files that I upload for the class here too. Okay. And so I'll put links to all the files in the weekly viewer, like I showed you before. But if you want to just look for a certain file and just download that quickly, you can come to this tab here, and you can see that I have page or folders for all the different homework assignments, lecture notes, live lecture notes. So what that means is that when I do lectures, I usually write on my iPad for that, and so you'll find the files here for that too. And any homework solutions, exam solutions that I put here too. So if you're just looking for a specific file, you can come here. Okay. But I'll also put all the links to the files in the weekly viewer as well. Okay. Okay. So I think that's everything you need to know about the website. So are there any questions on this before we talk about the syllabus? Okay. All right, so let's come back here. Oh, of course. Okay, so let's talk about the syllabus, okay? All right, so you can download the syllabus and you can follow along yourself if you want, but all the information will be here, okay? So office hours. So office hours will be virtual, okay? So you physically can't come to my office. Well, I guess you can, but I'm not going to be there. I'll be here in my apartment, okay? And here's all the times for you again, okay? And so office hours, typically what they're used for is if you're confused about anything from the lectures, or if you have questions on the homework or on the exam, you can come by in office hours to ask those. Or if you just want to stop by and say hi, that's fine too. Sometimes office hours are really busy. I think before an exam, typically they're pretty busy. But in the beginning of the semester like this, they're pretty empty. And so this morning, actually, I kind of just sat here and kind of just waited, but no one showed up. So if you want to stop by and just say hi, that's fun too. Okay. Okay. So here are the learning objectives. So we just talked about these, and so these are kind of our guiding. These are going to be kind of our guiding statements for the rest of the semester. Okay. And so I wrote these learning objectives such that by the end of the class, we're going to accomplish all of these things. Okay. And so as we go about the class, I want you to kind of read and, kind of keep these in mind and say, can I do these things? And, if I can't, what do I need to learn in order to do that? Okay. As you can see so far, we've already done the first one, right? And so you should be able to define and differentiate the 3 modes of heat transfer, right? So earlier today, we went through conduction, convection, and radiation, okay? And then throughout the rest of the class, we're going to work through the rest of the learning objectives. Okay? So these are course level. Right, so these are going to be our learning objectives for the entire course. Okay, homeworks and exams. So right now I've planned 8 homework assignments, 2 midterm exams, and 1 final exam. Okay, and so just like I usually do, the lowest homework will be dropped, right? Because I know things happen throughout the semester, so I want to give you guys some flexibility so that you can kind of skip a homework assignment if you have to. But please do them all. Because the homework assignments, I write them with the intent to give you practice for the exams. Okay, and so usually what I like to do is that for my homeworks, I ask some pretty tough questions on the homework. So, but the hope is that if you can do the homework assignments, the exams will kind of be one step down from that. So the exams will be a little bit simpler and a little bit easier problems than the homeworks, right? And so if you can do the homeworks and you can you really know them well, you're going to be really well prepared for the exams. Okay. In terms of grading the homeworks too, typically what I like to do is I like to grade every single problem for correctness. But because it's a virtual semester, and actually my teaching load just went up this semester too, I'm only going to be grading one of your problems on the homeworks for correctness. Okay. And so basically for every homework, I'm going to choose one problem, and I'm going to grade that one for correctness, and that'll be worth half the points on the homework. And then the other half of the points on the homework will be for completeness. Okay. And so if you do every single problem and I see that you gave it a good effort, you're going to get full credit for completeness. And then the other half of the points will be from that one problem that I choose to grade. Okay. So that mostly is just to kind of speed things up for me for grading. Okay. And no, I'm not going to tell you what problem I'm going to grade. So that's that's going to be usually I don't decide that until I actually sit down and grade that. So do all of them, and do them all well. Okay. Okay. So the midterms, their midterms are not going to be cumulative. So because I know, throughout the semester, things get really busy. So, I want to kind of limit those. But the final will be cumulative. Okay. So I will expect you to know things from the past 2 midterms for the final exam. Okay. But the final exam is not going to cover everything either. So the final exam, typically what I do is I choose certain topics. It roughly equates to be about 75% of the class that I expect you to know for the final exam. Okay. And before every exam, I do give you guys a study guide. And lately, I've been recording a review session video too to kind of help you study for the exams too. Okay, yeah, so there's a great question in the chat. So last semester, if you had me last semester, that I did 24-hour exams. But this semester, I'm going to be changing that to exams that are going to be basically in the class. So they're going to be 75-minute exams. Okay. And so because of that, the exams are going to have to be shorter. So they're going to be much shorter than before. Okay. So I think typically for my midterm exams, what I do is I ask you 4 short answer questions and 3 problem solving questions. And so this semester, I'm going to cut both of those down by 1. So there's going to be 3 short answer questions and 2 problem solving questions, right? Just to make sure that, it's much more reasonable for you to finish within the time and for you to upload your solutions. Okay. And so the reason I'm doing that, so before, I like the 24-hour exam because it kind of gave you guys, the flexibility. But there were a lot of issues with academic dishonesty last semester. So, I do want to cut down on those. So, the exams will be timed this time. They're not going to be 24 hours. Yeah, but they will be shorter. Yeah. Yeah. Some people were saying the exams took them a long time, so they'll be a lot shorter. Yeah, and I'll time myself too on the exams and be really strict on them. Yeah, there'll be simpler problems too. Yeah, last semester I kind of was a little bit lax in timing myself for the exam. This semester, I'll be really strict about how much time I give myself for the exam. So I'm going to aim for when I do the exams, for midterms I should be able to finish them in about 10 minutes, and then that should give you guys plenty of time to do the exams. And then for the final exam, I'll aim for something like 15, 20 minutes. Yeah, the exams will be open notes. It's virtual, so I can't stop you guys from doing that. So you can use the notes, you can use the lecture videos. And so the only thing I ask you guys not to do on the exam is to talk with your other people in the class. And so the exams what I want you guys to do is I want them to be individual efforts. And so, I don't want you guys discussing it, but you can use whatever notes and whatever, lecture videos, textbooks that you want. Okay. And so here are the dates that we have planned for the exam. So the first midterm is going to be on Wednesday, March 3rd. The second exam is going to be Wednesday, April 21st. And then our scheduled final exam is going to be Wednesday, May 19th, at that time. Okay. And so these are flexible still. So, it'll depend on how we progress through the semester, but these are kind of the plans, right now. Okay. Okay. Any other questions on the homeworks or exam policies? Okay. Okay, so here's how the grade is going to be broken down. So the homeworks are going to be worth 20% of your grade. Each of the midterms is going to be 20%, and then the final exam will be 40%. Okay, and then once all the grades are in, depending on your cumulative score, here's how I'm going to assign the points. Okay, or the letter grades. Right, so pretty standard stuff. So I haven't had to do this in a couple semesters just because of the virtual instruction. But if I see by the end of the semester that the class average is below 75%, then what I do is I add points to everyone's grade such that we get the class average up to there. Okay. I'm going to tell you right now that the past couple of semesters I haven't had to do that. But I do want to tell you guys that I do scale the grades if the class average is kind of below 75%. Okay. Okay, course textbook. So the course textbook is required. It's a really good textbook. So it's definitely look into it. But you don't have to use this edition. Okay. So you're not going to need the textbook because I don't assign readings and I don't assign problems from the book. But it's still a really good reference because the textbook will have figures, have examples, it'll have explanations that go, more in depth than what I can cover in the lectures. Okay, and so it's just kind of a good resource for you to have. Okay, and I tell this to people every semester. Find a cheap version. So try to find one that's really cheap. And off the record, if you can find one that's free through means that are less than legal, definitely partake in that. Okay. Just because the textbook industry is run by the mafia, and if we can avoid giving money to the mafia, then I'm all for that too. Okay, and so textbook's really good. You should definitely pick one up, but don't stress about don't pay $100 for it because it's not that good. Okay. Okay, so course website. So we just went through this. So on Canvas site. I'll post basically any material that I produce for the class, which whether it be lecture notes, lecture slides, homework assignments, solutions, study guides. I have a couple extra study guides for this class that I prepare in the class in the past. Those will be on Canvas for you. Okay. Announcements, they'll be made through Discord. Through Canvas. And those will be emailed to you. And the Discord server, we've talked about before. So it's kind of a nice place to kind of informally meet people. Okay. All right, course policies. So homeworks. So we already talked about the lowest homeworks can be dropped, but late homeworks I do accept too. And so if you don't make the original due date, please still do the homeworks. But because the homework's late, I do have to dock some points. And so my policy for late homeworks is that each day that it's late, I dock 10% from the allowable points. Okay. And so if because it's virtual, you'll all be turning in the homeworks on Canvas. So you'll be scanning a PDF and turning it in that way. But if for some reason Canvas isn't available, you can also scan your homeworks and email them to me as well. Okay. Okay, regrades. And so if you I make mistakes all the time. If you had me before, I make mistakes a lot. And so that includes, grading your homeworks and exams. Okay. And so if you want me to take another look at your homeworks and exams, you think you deserve some more points, definitely I'm always open to discuss those things and look at them. But please make it within a week after I return it to you. Okay. And so don't come to me in week 15 of the semester and say you want to regrade on homework 1. Okay. Cause that's way too long. Okay. And the reason for this is, when I grade your materials, I'm leaving comments for you to give you feedback. Okay. And I want you to be looking at that feedback kind of as not necessarily right after I post it, but, within a timely manner. Okay. And the reason for that is, if you're looking at feedback that I gave you in week 1, in 6 or 7 weeks later, that's not that useful to you. Right. And so I want you to be looking at that feedback, as soon as you get it. Okay. Cause that's when it's going to be most useful to you. Okay. And so I have this 1 week policy on the regrades to kind of encourage that. Okay. So, when I grade something, when I return something to you guys, please, take a look at it, as soon as you can. And any mistakes that I make, please let me know. And, I'm always happy to fix those. Okay. Okay. Emails. And so emails, a lot of you guys have been emailing me. I know some of you guys have emailed me throughout the course of this class, which is great. Okay. But when you're emailing me, I'm teaching 4 different classes this semester. So, just so I know that you're emailing me about heat transfer, make sure you put EGME 407 in the subject line, okay? And put it in the square brackets if you can, because then it gets picked up by my email filter, okay? Because that just kind of just helps me, when I read your email and you ask me to look at homework 3, I know that it's for heat transfer homework 3, okay? Because if you don't do this, then it takes me some time to kind of figure out exactly what you're asking for, okay? And so if you do that, I promise that I'll respond to your emails within 48 hours. So, except on weekends. On weekends, I try not to answer my emails too much on the weekends, but I do look at my emails on Sundays too. But but if you do email me, I do promise a fast response. Okay. So academic dishonesty. So this is not my favorite thing to talk about in this semester. But considering this kind of was happening throughout the entire department, actually all last semester, it's worth talking about. Okay. And so academic dishonesty, just because it's virtual, doesn't change anything. It's not going to be tolerated in this class, right? And so any kind of academic dishonesty, at the very least will be a 0 on that assignment. And if it happens on something big on an exam, that can result in an F in the course. Okay. And so, of course, this applies to, copying answers from someone on the, from someone else in the class. But what happened a lot last semester too was people were posting questions on online forums and online resources too. Okay. And so please don't do this. Okay. Because at the end of the day, you're in this class to learn, right? And I know it can be really stressful, with a lot of other classes, but if you cheat, that's something that you're not learning, okay? But if you ever do feel like you're struggling in the class, or you're not understanding, or you're not going to turn something in on time, or you're stressed about the exam, please, give me a chance first before you resort to cheating. Okay. I promise you that I'll do everything in my power to help you, understand the material and succeed in this class as much as I can. Okay. Because, at the end of the day, I want everyone to succeed in this class. Right. The only thing I ask is just kind of a chance to do so. So, please reach out to me. We'll set up office hours. I'll write more examples for you. I'll do, whatever it takes to kind of, help you out with the class, as to the best of my ability. But just please don't cheat. Okay. And so with that, we've come to the end of our first lecture. So the last thing I want to talk about is your first homework. Okay. And so your first homework is just to simply send me an email and just to introduce yourself. Okay. And so if you do that, and you'll get full credit for you. Okay. And so in your email, please include your name, your year, and your major. Okay. And just, if you're struggling to find out what to talk about yourself, here's some questions that you can answer just to kind of help guide you to get started. Okay. And so you can answer, what kind of career do you want after graduating? What do you want to learn most? Do you have any worries or concerns about the class? And just, what are your interests and hobbies? Okay. So you don't have to answer all of these questions, but they're just kind of, kind of conversation starters to kind of get you started. Okay. And so that's going to be due by this Friday, January 29th. So please, send me an email. I'll respond to your email. This is my favorite part of the semester. So I always like reading your guys' emails and responding to them. So just make sure you get that in before Friday. Make sure to put EGME 407 into the subject line, just so I know what class you're in. For this one, it's especially important. So when I'm going in and grading, it's easy for me to just look up 407 and then everyone's name shows up, and then I just, give everyone full credit for that. Okay. Are there any questions on anything that I talked about today? Okay. Question? Yep. One of the main games I play. We'll talk about that after. Okay. I'm gonna end it a little bit early today. So usually we're gonna go until 3:45. But in the last 15 minutes, we can't really cover much. So I'll end it here. But I'll stick around for, we can talk about gaming, afterwards too. But I'll stick around and answer any questions you have. So thank you everyone for tuning into our first lecture. And I'll see you guys on Wednesday.
Professor, I had a quick question about the files that you posted for the lecture notes.
Yeah. What's up?
Was the convection notes for the next class period?
Yeah, conduction notes will be for the next class period. Yeah.
Okay.
Yeah.
And
so
then,
I posted by week, so then all the lecture notes for the week will be there.
okay, got it. Cool. All right. Thank you.
Mm-hmm. Shadowbox. I'm not here for your entertainment. There's some things I'll do, but I won't shadowbox for you. So what games do I play? So I play a lot of Japanese RPGs actually. So JRPGs have kind of been the genre that I've loved ever since I was young. But lately, actually surprisingly, the game I've been playing with my friends a lot is Bloons Tower Defense. And so over Steam, so if you know Bloons, it's a tower defense. It has its roots in kind of like old browser Flash games. So it's very simple graphics, but it's still very fun. So it was $1 over the Steam winter sale. So me and a bunch of my friends, we picked it up and we've been playing that one a lot actually. So it's been fun. Yeah, I think my friends got into it because I think some people were streaming it or something, and then they told me to buy it because it was $1. So yeah, we've been playing that one. They play it a lot more than me, so they're like over level 100, but I'm still like level 60 something. But we play it at least 3 or 4 times a week. Yeah. FPS? No, I'm terrible at FPS games. So the only one that I played for a little bit was Overwatch, but I was terrible at that. So so I don't play that too much.
Have you done Alien Isolation?
Isolation?
Yeah.
Is that a mode on Overwatch?
No, it's Aliens, the movie. Alien Isolation it takes place between, I forgot what 1 and 2 or one, like within that.
Mm-hmm.
And it's just like kind of like a horror single player game.
Okay. Yeah, I've not played that, but I really don't like horror movies. So I've stayed away from horror video games too. Yeah, Rocket League, I've tried it, but I'm also very bad at Rocket League too. But I know a few of my friends are really into it. So he's actually spent like entire afternoon trying to teach me one time. But I was not that good. My reflexes are not that good. So actually, like, you know, a few weeks ago I took like a reflex test, and I was like in the bottom like 15 percentile in America in terms of reflexes. So, and I actually tried it like 6 different times until I got a good one, and was still like bottom 15%. So my reflexes are not good. Persona 5, yes, it's one of my favorites actually. I played it last year, and I really liked it. Yeah, it was a great game. Genshin, yeah, I played Genshin Impact for a little bit too, but the gacha kind of turned me off from it. So, but some of my friends still play that quite a bit. It's a beautiful game. I think it's really well made. It's just yeah, too much randomness for me. Gang Beasts. Oh yeah. That's the one where like the guys kind of look like Play-Doh, and you kind of like try to push each other and grab each other and throw them off the car or something, right? I think I've played it wasn't Gang Beasts, it was something similar. I think the physics are similar to Gang Beasts, but it's like kind of a cooperative game. I think it's I actually have it on Steam. Let me see. Call it Fall Guys or something. Or Human Falls Flat. Yes, I play that one with my friends. Yeah. What else do I do other than game and teach? So I feel like I'm a Twitch streamer right now. I like to cook, so I've been cooking a lot more with my free time during the pandemic. So I really like to cook. I have a cat, and so a lot of my time is spent taking care of my cat too. She's old. She's an old lady, so she's almost 16 years old now. So she's diabetic, and you know, she's on a strict diet. Half my day is like yelling at her that it's not time for her meal yet. Yeah.
Have you got into 3D printing at all?
No, I haven't, but a lot of my friends are. I don't own a 3D printer myself, but when I get the chance to try one, I do like using it. But I know a lot of people are, you know, they have like a setup on their desk for 3D printing, which is really cool.
Yeah, it's fun. I've been making parts out of mine.
Nice.
Quick question.
Mhm.
Is it possible for me to go to as a SolidWorks teacher for a key for SolidWorks, even though I'm not taking that class, or do I
I'm
have to
sure.
take the class in order to get the SolidWorks key?
I
Because
think
you know how they do the student thing.
Yeah. It's going to depend on the instructor. I actually don't know how the licenses work for SolidWorks, but at the very least, I don't think it hurts to ask. So I don't have access to those things. I think the SolidWorks professors have those. But I think, you know, it definitely wouldn't hurt to ask, especially if you're going to use it for like a student project or something like that. You know, I think they try to secure something for you. But yeah, SolidWorks is kind of tricky because they don't have like a free student version to it. And I think, you know, the way it works, I think the department buys a certain amount of licenses before the semester. But you'd have to talk to one of those professors. Yeah.
Okay, thank you.
Mm-hmm. Thanks, guys. Yeah, see you Wednesday. What did I do for my PhD? So my PhD, I did research on blood flow. So actually, you know, heat transfer is kind of a side love for me. So I love heat transfer, but it comes actually a lot more from like my interest in cooking. And so actually throughout the semester, you'll see a lot of examples of like from cooking and how heat transfer relates to that. But my PhD was actually much more in fluid mechanics, especially seeing, you know, if we can use fluid mechanics to study cardiovascular disease or to better design medical devices. So that was the subject of my PhD. Thanks, guys.
Thank you, Professor. Have a good day.
Thanks, you too. Thanks, Ahmed. Andrew, did you have any more questions?
No, I'm good.
Okay.
Have a good one, Professor.
Thanks, you too. See you Wednesday.